Chapter. And back to this. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. And there you have it. So today, we're going to start off with answering questions from the second part of section 9.1, and then we'll go on to section 9.2. All righty. And what I'm going to do right now is switch screens. If I can find out where my mouse is. There it is. Okay. And we're going to take a look at this particular problem. It says graph the function, the cube root of x plus 4. Okay. So the cube root of x plus 4. Now, initially, I was going to, switch over to the graphing screen and do all that. And I will do that ultimately if need be. But with just a few basic things, we can actually determine which of the 4 graphs this is. First of all, take a look at where x is. X is inside the cube root. The 4 is not. Okay? The x is inside the cube root. So what would the domain of this function be? Well, since we're taking an odd root, the quantity inside can be positive or negative or 0. That means that x could be any real number. So the domain of this function is all real numbers. Why is that important? Well, look at this graph right here. This starts when x is 0 and y is 4. If the domain is all real numbers, there should be some graph over here. So already we can eliminate this graph in the lower left-hand corner. Any questions about that? Okay, let's go back up to this function. Suppose x is 0. What is the cube root of 0?
0.
0. So if x is 0, f of 0 would be the cube root of 0, which is 0 plus 4. So when x is 0, y is 4. So that means the point 0, 4 is on the graph. Well, this graph has the point 0, 4. This graph does not have the point 0, 4. It has the point 4, 0. So this graph can be eliminated. So we've already eliminated this one and this one down here. Now this last graph also has the point 0, 4. Okay, but so far we've eliminated this one and this one. Let's go a little further. Let's say that x is 1. What's the cube root of 1?
1.
1. Okay. So if x is 1, y would be the cube root of 1, which is 1 plus 4 would be 5, right? So when x is 1, y is 5. Let's take a look at this graph. When x is 1, maybe y is 5. Okay, so that's a possibility. How about here? X is 1, y is 5. Oh, that didn't really do it, did it? Okay. Let's get more. Well, let's see. What if x is 2? All right. Well, if x is 2, the cube root of 2, that's not very nice, is it? Cube root of 2. Well, how about the cube? Let's do the cube root of 8. What's the cube root of 8?
2.
2. Okay.
2.
So if x is 8, y would be the cube root of 8, which is 2 plus 4 is 6. So the point 8, 6 should be on the graph. Well, 8, 6, it doesn't look like it. Over here, how about 8, 6? What do you think? Nobody's willing to commit? It's got to be this one.
It's got to be that one.
Yeah. All right. Is that enough to convince you, or do you want me to go ahead and do a full graph of it? I will if you need me to. I'll take that as a no. Okay, we're going to go on and take a look at problem number 15 here, which says, use a calculator to solve the problem. Round your answer to the nearest tenth. The function s of g equals the cube root of the quantity g divided by 7.5. This determines how long in feet an edge of a cube-shaped tank must be if it is to hold g gallons of water. What dimension should the side of the cube-shaped aquarium be if it is to hold 1,300 gallons of water? Okay, so basically what we're going to do is we're going to find S of 1,300. All right, so let me write that information down on my other board. S of 1,300 is going to be equal to the cube root of 1,300 divided by 7.5. Okay, and so I need to put that into the calculator. Now, can everybody see my whiteboard screen here? Did I?
Yes.
Okay, thank you. All right, now the problem is we've talked about square roots, but we haven't talked about cube roots. And I want to deal with this in a couple of different ways, depending on which calculator you have. All right, now, if you have the one that was listed for this class, the TI, what is it, 30X Roman numeral 2, over on the left side column, so here's the calculator, over right over here, there's a button that's a square root button, and I believe it's a second function key. There's another button that has a little X in the index, okay? And it looks like this. Now, if you have a calculator with this button, what you need to do to take the cube root, first of all, with the calculator clear, so you've got nothing, it's on, but there's just like a 0 there, okay? You're going to put the index in first. So you're going to put in the number 3. Then you're going to do, I believe it's a second function, and then the x root of that, okay? When you do that, if it puts parentheses, great. If it doesn't, go ahead and put a left-hand parentheses. Then you're going to put 1,300 divided by 7.5, close parentheses, and then equals. All right, so let's try that. And let me see here. I'm going to put in 1,300 divided by 7.5. I'm getting 5.5756, on and on and on. And it says, it said in the directions, round your answer to the nearest tenth. So it would be 5.6 feet. Now, does anybody have a different calculator that you want me to help you get through to get that answer? If so, now is the time to speak. All right, and we'll go on to number 16 on this same set of problems. And it says, the graphs of two radical functions shown, radical functions, so these are like a square root or a cube root or something like that. An illustration can be used to estimate the speed in miles per hour of a car involved in an accident. Suppose the police accident report listed skid marks of 220 feet long, but failed to give the road conditions. Estimate the possible speeds the car was traveling prior to the brakes being applied. Okay, now, basically we're going to read the graph. So can you see my arrow moving around on the graph? Yes?
Yes.
Okay.
Yeah.
So 200, it looks like each one of these little hash marks, let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. Each one of these hash marks is 1/5 of 100 or 20. So 220 would be right there, okay? So wet pavement, it looks like it's 40, it's between 45 and 50, okay? And if I had to guess, I would guess, I might go like 47.5. And you can see up here, the correct answer is 47, okay? Oh, here it says round your answer to the nearest whole number. So I might try 47 or 48 until one of them worked. I won't give you a problem like this on the test where you've got to really do a fine estimate. You don't get a couple of guesses, okay? Now let's go back to the 220 and go up here for dry pavement. That looks to be about 72.5. So I might try 72 and 73. And it turns out the correct answers are the 47 and the 73. All right, any questions about that problem? All right, I'm going to get off of that screen and go back here and then go to another set of problems on WebAssign. So give me just a minute here. Let's see, we are in 4780. That's not the one I wanted. Try that again. Here we go. I can't walk and chew gum at the same time. And that was this one. And this is number, let's see, 9.1, 9.1, part 2. This is number 21. Okay. There is no number 21 on 9.1 part 2. Interesting. So obviously I've got the wrong question for this person. So I guess I'm going to come back to that one. Sorry about that. And I'll check in with that person later. Okay, let's see, 4770. And here, 9.1 part 2. Question part 1. Hey, okay, here we go. Sorry about that. So we're looking at problem number 1, part A. Okay. It says, find each function value if possible. Do not use a calculator. If the answer is undefined, enter undefined. Okay. And this is back where I said I disagreed with the author. I would have said there's no solution, but because that's the option they're giving, if you think it's undefined, you can see here that part B, they've said it's undefined. All right, but let's take a look at part A. We've got h of t equals the square root of t squared plus t minus 33, and we're supposed to find h of -7. Okay, so here we go. So this means I'm going to have the square root of the quantity -7 squared plus -7 minus 33. Now note, -7, the quantity is being squared. So that means that negative sign is part of the base inside. -7 times -7 is 49. So we've got 49 minus 7 minus 33, which is 42 minus 33, which is 9. And what is the square root of 9? 3. So there's the correct answer to that problem. Okay. Any questions about that? All righty, we're going to go to another set of problems. Let's see here. There. And here. And 9.1 part 2. Number 2. Okay. And so now we'll take a look at this particular problem. It says use a calculator to find each value round to the nearest 10,000th. So I've got g of x equals the square root of 9 minus 4x. Then I'm to find g of negative pi and g of 0.5. Okay, so let's go back here. G of negative pi. Well, that would be the square root of 9 minus 4 times negative pi, which would be the square root of 9 plus 4 pi. Okay, so now on your calculator, you need to find the pi button. Again, if you have the TI-32 whatever kind of thing, I believe that it's over, let's see here, it's over on this side of the screen, somewhere right around there, I think. Okay. So let's go back and do that. What I'm going to do now, I'm going to put in the square root, parentheses, 9 plus 4 times, push the pi button, parentheses, equals. Okay. And again, if you're having difficulty getting that to work, go ahead and ask me about it here if you want, and we'll try and see if we can figure that out. And it said to the nearest 10,000th, I'm getting 4.64396066. 10,000 would be right there. Tenths, hundredths, thousandths, 10,000ths. The 6 would round up, so I'm going to get 4.643. Oh, that's going to become a 40. So 4.6440 would be the correct answer, 4.6440. Any questions about that? Okay, then we're going to go back and do the second calculation, which is the square root of 9 minus 4 times 0.5, which is the square root of 9, 9 minus, what's 4 times 0.5? That would be 2. So this is going to be the square root of 7, which is 2.645751, etc., etc. So here, rounding that up, we get 2.6458. So that would be the answer to the second question. Are we okay with that?
Yes.
All right. Let's see here. Oh, I guess I was on this screen anyway, wasn't I? All right. And now let's go to, let's see, 4770. And there's this one. And this is 9.1, part 2. Okay. All right. I'm looking at this problem, and I believe that this is the exact same one we just did for a different person. Okay, those are the same numbers. So I'm not going to redo that problem. We'll go down to number 7. And okay, so this is very similar to the first one we looked at, and I'm going to approach it the same way. And then if you need more information, let me know. First of all, we're taking a cube root, so x can be any real number. So the domain is any real number, which means it's not going to be this second one over here, because this does not include negative x values. Okay. If x is 0, the cube root of 0 is 0. 0 plus 6 is 6. So the 0.06 should be on the graph. This has the 0.06, so it's a possibility. This has the 0.06, so it's a possibility. This does not have the 0.06. So now we've eliminated this one. So we've gotten rid of the second one and the fourth one. Okay. Let's go with 8 again. If x is 8, what's the cube root of 8?
2,
What's 2 plus 6?
8.
So when x is 8, y is 8. Does this have the point 8, 8 on it? Doesn't look like it. Does this have the point 8, 8? Yes, it does. So here is the graph. All right. Any questions on that? Let's take a look at problem number 14. Okay. So it says use a calculator to solve the problem. The time t in seconds that it takes for an object to fall a distance of s feet is given by the formula t equals the square root of s over 4. In some places, the Grand Canyon is 1 mile or 5,280 feet deep. How long will it take a stone dropped over the edge of the canyon to hit the bottom? All right. So S, up above, it says S is the distance in feet. So T is going to be equal to the square root of 5,280, all of that divided by 4. Now, it's important to note that the 4 is not inside of the radical. It is not the square root of 5280 over 4. It's the square root of 5280 over 4. Okay, so on my calculator, square root 5280, close up the parentheses. So I've got this, close it up, then divided by 4. And when I do that, I get 18.1659, blah, blah, blah. Let me go back to the other screen so you can see what I'm doing there. So I'm putting it into the calculator like this, closing that up before I divide. And it says to 1 decimal place. So the second decimal place, the 6 would round up. So you'd have 18.2 seconds would be the answer. All right, with that. Okay, we're going to go on to the next problem, which is, whoops, number 15. And it says use a calculator to solve the problem. Round your answer to the nearest 10th. The function s of g equals the cube root of the quantity g over 7.5. Unlike the last problem where the 4 was down below the radical, here the 7.5 is included in the radical. And so we're going to find s of 1450. Okay, rounded to the nearest 10th. So I want the cube root of the quantity, 1450 over 7.5. And rather than take 1450 and divide it by 7.5, I could do that, but let's see if it comes out to an exact number. 1450 divided by 7.5. It doesn't. It comes out to 193.3 repeating. So I don't want to simplify that first. What I'm going to do, the same thing I did earlier, I'm going to clear my calculator. I'm going to put in a 3. Then I'm going to get that xth root of whatever, a left-hand parenthesis, 1450 divided by 7.5, close it up, and then equals. Okay, so let's see what we get there. 1450 divided by 7.5. And I get 5.782322165, round to the nearest 10th. The 8 and the 100 spot would round up, so you'd get 5.8 feet. Okay. Any questions there? And then number 16 on that same page. So we're going to go back to the picture, and this is very similar to the one we did earlier, only here instead of it being 220 feet, it's 240 feet. So 200, 220, 240. Wet pavement, it looks to be 50. And I see that their answer is 49. And based on the picture here, I think I would argue with them in court over that. But again, you know, they're wanting a whole number. So I would say, if when you're trying it, if it's not working for the 50, to try the 49, the 51. And again, you shouldn't have something like this on your test to deal with. And then dry pavement would be between 75 and 80. That looks to be about 76 or 77. I think I'd try 76. When that didn't work, I'd try 77. All righty. So that's all the questions except for that one that apparently I was confused because there wasn't a number 21 on that assignment. I'll check back with that student later, but we're going to go on to look at the new section. So here we go in section 9.2. Oh, I'm sorry. Were there any questions from anyone else that didn't email them in first? Or are we good to go on? I guess we're good to go on. All right. The big deal in section 9.2 is this. The index of a radical is the denominator of the exponent if you write it in exponential form. Huh? All right. The cube root of 8 would be 8 to the 1/3 power. The index on the radical is the denominator of the exponent if you write the problem in exponential form. So the cube root of 8 would be equal to 8 to the 1/3 power. Let's say we had the cube root of 8 squared. That would be equal to 8 to the 2/3 power. So the exponent is still there on top. The index becomes the denominator of the exponent. So the cube root of 8 squared would be 8 to the 2/3 power. Excuse me. So we can do a problem using radical notation. We can do a problem using exponential notation. Any questions so far? All right. So in general, we could say x to the 1/n power is equal to the nth root of x. Again, the denominator of the exponent is the index, or the index is the denominator of the exponent. All right.
I have one question about this.
Yes, Roger.
So for one that's like 8 1/3, would it be, would
That
the
one?
answer be like 2.33?
Nope. Here's what you did. You did 8 to the 1 and then divided by 3 power, right?
Oh, okay, yeah.
What you need to do is this. Because otherwise, if you put this into your calculator, the calculator thinks you have 8 to the 1 power divided by 3. So you need to quantify the 1/3 so that the calculator knows that it's 1 divided by 3. That whole thing is the exponent. But thank you for asking, because that's something I was going to cover, but now
Okay.
we've got it covered. So
Thank you.
yeah, so in fact, let's take a look at 8 to the 2/3 power. If I put this into my calculator, that's going to be 64/3. I need to put 8 to the 2/3 power. Okay. And we're going to explore that a little bit more. Let's take that 8 to the 2/3 power. which is the same thing as what? The cube root of 8 squared. Okay, now, it's also the same thing as the cube root of 8 squared. Huh? Well, let's take a look at this problem. Order of operations, what would you do first? You do inside the grouping symbol. What's 8 squared?
64.
So this would become that. What's the cube root of 64?
Four.
Right, 4. Okay, now let's take a look at this one. Let's do inside first. What's the cube root of 8?
2.
And what's 2 squared?
4.
So you get the same answer whether you do the exponent first or the index first. And that's one of the rules in the book, is that if they're both real, if both the root and the power are defined, you're not taking the even root of a negative number, you can either do the power and then the root, or the root and then the power. Generally, it's going to be easier to do the root and then the power, because here you're tearing down something small and then making it big. Here you're taking something and making it bigger and then trying to tear it down. It's easier to deal with a root of a smaller number. In fact, let me see here where they have that. In the book, it looks like this. It says x to the m over n equals the nth root of x to the m power, and x to the m over n equals the nth root of x to the m power, as long as they both represent real numbers. Okay, so in other words, you could do the root first and then the power, or the power first and then the root. Okay, and that's going to come in handy. Now, I want to go back to 8 to the 2/3 power, and let's do this on our calculator. Let's do it on our calculator using exponents. So I'm going to put in 8, then I'm going to use the little caret key saying I'm raising it to the power, parentheses 2 divided by 3 close parentheses equals. And I believe we already determined that this was 4. So let's see if we get that. I get that. Did you? And if you didn't, you probably didn't put these parentheses around the exponent. Okay? All right. One more example. What's the square root of 4?
2.
2. Okay. Now, how would you write the square root of 4 using an exponent? What would the exponent be?
1/2.
Where did you get the 2 from?
From the square root of 4.
Sorry, Anthony, we couldn't hear you.
From the square root of 4.
Boy, still garbled, but I'll help you. The index is a 2, right?
Right.
Yeah. I don't know, for some reason your microphone's all garbled there, but anyway, so 4 to the 1/2 power is the same thing as the square root of 4. 9 to the 1/2 power would be the same thing as the square root of 9. So what's 9 to the 1/2 power?
3.
3. Good, good. Okay. Now, some of you took Math 85, some of you didn't. Back in chapter 5.2, there are a whole bunch of rules to do with exponents. Okay, we explored several of them when we looked at the end of chapter 5. That was like the second test that we had. Okay, I think that was the second. Yeah. So this section coming up, we're going to need to use those rules of exponents. They still apply when the exponent is a fraction. All right. So one of the rules says a to the m times a to the n equals a to the m plus n. So for example, 7 squared times 7 to the 4th power is 7 to the 6th power. Are you okay with that? Now, what if I had 7 to the 1/2 power times 7 to the 1/2 power? That would be 7 to the 1/2 plus 1/2 power, which is 7 to the 1 power, or just 7. And maybe I should have done this. This is 2 plus 4 power, which is 7 to the 6th power. In other words, when you're multiplying two powers with the same base, you add the exponents. Are you okay with that? Any questions? All right. Another rule. When you're dividing two powers with the same base, you subtract the exponents. So if I have x to the 5th power over x squared, that's x to the 5 minus 2 power, or x cubed. All right, let's do that using fractional exponents. Let's say I have y to the 4/3 power divided by y to the 1/3 power. That would be y to the 4/3 minus 1/3, which is y to the 3/3, which is y to the 1, which is just y. Any questions on that one? All right, another rule. Let's see. If you have a power raised to a power, you multiply the exponents. So x cubed squared would be x to the 6th power. Let's say I had y to the 2/3 power to the 1/6 power. That would be y to the, let's see, 2/3 times 1/6, which would be y to the 1/9 power, because 2 over 18 would reduce down to 1/9. You see how this is working? It's awfully quiet out there.
It makes sense so far to me.
Okay, well, at least one of you is on board. We'll hope for the rest of you. Let's see here. If I have a product raised to a power, I attach that power to each factor inside. So for instance, if I have 2x cubed, that's 2 cubed x cubed, or 8x cubed. If I have 4y squared to the 1/2 power, that would be 4 to the 1/2 y squared to the 1/2, which would be 2y. Because the square root of 4 is 2, and here we'd multiply the 2 times a half and get a 1. Y to the 1 power is the same as just y. Okay, another rule. Let's say you've got a to the negative r power. That's equal to 1 over a to the positive r power. So 7 to the negative 3 power is equal to 1 over 7 cubed, which is equal to 1 over, let's see. Whoa, 7 cubed. 7 cubed is 343. Don't drop your calculator. It makes everybody, yes, whatever. Okay. Let's say I've got 4 to the negative 1/2 power. That's 1 over 4 to the 1/2 power, which is 1 over 4 to the 1/2 power is 2. What is a to the 0 power?
A.
1. Remember, any number to the 0 power equals 1. What is a to the 1 power? That's just equal to a. So if there's no exponent written, it's an implied 1. If the exponent is a 0, then the whole thing is a 1, unless it's 0 to the 0 power, and we generally don't go there. So all of this is back in section 5.2. I don't know if the ebook corresponds in the same pages as the regular textbook, but in the regular textbook, they're all outlined on page 364. Okay. Anyway, I want to take a look at a few problems here applying these rules. Let's say we've got 81 to the 1/4 power. So that's the same thing as the 4th root of 81. What would that equal? So what times itself times itself times itself is 81? Well, is it 1? 1 times 1 times 1 times, no. What do you think, Roger? What?
I think it's 3. 3.
3, yeah, it's 3. So 81 to the 1/4 power is 3. The 4th root of 81 is 3. And you could put both those into your calculator. You could go 81 to the parentheses 1 divided by 4 power equals, or you could go 4 and then use the x root and put 81 in there, and you should come up with 3. Okay. How about this? 25 a to the 8th power to the 1/2 power. Now, it says, simplify each expression, assume that the variables can be any real number. So earlier they said, assume the variables are unrestricted. Now they're changing the directions, but it means the same thing. They're saying can be any real number. All right. Use absolute value symbols when necessary. Okay. So I have a product raised to a power. So that means each factor in the product gets raised to a power, the outside power. Now I've got, what is the 25 to the 1/2 power? That's the square root of 25, which is 5. And then here, a power raised to a power. Let's see, power raised to a power. What do? You multiply the exponents. Okay. But what is 8 times 1/2?
4.
4.
Now, I took an even root, so I need to make sure I don't have any negative variables. Do I need absolute value bars on this? No, I don't, because even if a is negative, raising it to an even power is going to make it positive, right? Okay. Let's see here. How about this? Evaluate each expression. Negative 100 to the 3/2 power. So we're going to cube it and take the square root of it. Let me ask you this. Is the base 100 or is the base negative 100? Let me answer it for you. The base is 100. If I wanted the base to be negative 100, it would look like this. This is not real because you can't take an even root of a negative number. This, it's as if though it's a -1 times 100 to the 3/2 power. Okay. If you want the negative sign included in the base, it's got to be grouped. So now I've got -1 times, let's see, 100. I'm going to take 100 to the 3/2 power. I'm going to do the root first and then the exponent. What's 100 to the 1/2 power?
10.
Good. What's 10 cubed?
1000.
Good. So my final answer is -1000. Now, I'm going to go back and instead I'm going to do the power and then the root. So I could do it this way. I could say, well, what's 100 cubed? and then to the 1/2 power. Well, what's 100 cubed? That's a big number, isn't it? You're gonna
5,
have-
isn't it? Oh, 100.
I think you're going to have 6 zeros.
I thought you meant to the cube root.
No, cube here. So 100 cubed. So 100, oops, 100 cubed is 1 million. What's the square root of 1 million? It's 1,000. So we get negative 1,000. Now, again, which was easier to do? The first one or the second one?
The first one.
Good job. Good job, young Padawan. You have chosen correctly. All right. Now, how are we doing? I got a few more minutes here. What about this? 4/9 to the 3/2 power. If you have a quotient raised to a power, you attach the power to both the numerator and the denominator of the quotient. Okay? So a over b to the n power is a to the n over b to the n. And this is all going back to chapter 5. So 4 to the 3/2 power, would you rather take the 4 and cube it first or take the square root of it first?
I take the square root of it first.
Good choice. So what's the square root of 4?
2.
And what's 2 cubed?
8.
Good. So 4 to the 3/2 power is 8. 9 to the 3/2 power. Let's take the root and then cube it. What's the square root of 9?
3.
And what's 3 cubed?
7.
1 sec.
27.
27. Good job.
There you go.
I stalled as long as I could. All right. Oh, how about this? 4 to the 2/5 power times 4 to the 2/5 power. When you're multiplying two powers with the same base, you add the exponent. So this would be 4 to the 2/5 plus 2/5 power, which is 4 to the 4/5 power. Now, the 5th root of 4 is not a pretty sight. So we're just going to stop there with that one. Okay with that?
Yes.
All right. How about this one? M n to the negative 2/3, the whole thing to the negative 3/5. So I have a product inside raised to a power outside. I'm going to attach the outside power to each of the factors inside. Okay. Now, m to the negative 3/5 power becomes 1 over m to the positive 3/5 power. Okay. Here, a power raised to a power, you multiply the exponents. So you'd get n to the, what, 6/15 power, because negative 2/3 times negative 3/5 would be 6/15. Negative times negative is positive. Oh, but could I reduce 6/15? Sure. That would be what, 2/5? So this is 1 over m to the 3/5 times n to the 2/5 over 1. But if I multiply that together, my final answer is going to be n to the 2/5 over m to the 3/5. So this is where Math 50 meets Math 85. That is, we're adding and multiplying and subtracting fractions as the exponents. Okay. Well, it's 11:20. That's all I've got time for today. I'll be back at 1:15 if you have any further questions. And as I said, I covered all the questions people had, except there was that one. You know who you are. if you want to contact me and clarify, I'll be happy to do a problem for you. Anyway, thanks so much, and I'll see you later.
Thank you.
You're
Thank
welcome.
you, Mr. Mail.